Some of the problems that you're going to work on in this thought primer are going to ask you to evaluate given arguments for validity using the traditional square of opposition and all of its rules and the operations of conversion, aversion, and contraposition. And I know you've done this before in previous thought primers, but the work you do in this thought primer is going to be more difficult because you're going to have to apply these rules and operations in combination with one another to determine whether or not an argument is valid or invalid. In other words, you're going to have to apply more than one rule or more than one operation to a given argument. And that can be super stressful and confusing and frustrating. And so what I want to do here is I just want to really briefly illustrate for you a process for approaching these problems that will minimize, hopefully, the amount of frustration you experience and allow you to complete these problems successfully. All right, so the first thing we want to do is we want to make sure we have our traditional square of opposition handy and that we have our definitions of aversion, conversion, and contraposition with us. And then we can look at our argument. All A are B. Therefore, some A are not non-B. Now, what I need to figure out is this. If I assume that premise statement, all A or B is true, is there some combination of rules or operations that I can apply to all A or B to generate the statement some A are not non-B and know that that statement is true? Because if I can, then I've proven the argument is valid. Now, the way I'm going to go about doing this is I'm going to begin by cataloging the differences that I see between the premise statement and the conclusion statement. One of the things I noticed right away is these statements have a different quantity. The premise statement is universal, all, but the conclusion statement is particular, some. I also noticed there's a difference in quality, right? All A or B is affirmative, but some A are not non-B is negative. And then finally, I noticed that the predicate terms of the premise and the conclusion are complements of one another. The predicate of the premise is B, and the predicate of the conclusion is non-B. So now, really, this is going to begin a process of trial and error. What can I do to that premise statement, all A or B, to begin eliminating differences that exist currently between these statements? Because my goal would be to eliminate all of the differences and wind up with the conclusion statement and be able to show that by some process of applying these rules and operations, I know this conclusion statement is true or not. All right, so one thing I could do, for example, is I could just throw a dart at a wall and say, well, okay, well, the premise is an A statement, and I know I can contrapose A statement, so what happens if I contrapose all A or B? And the answer is I get the statement all non-B are non-A. And that's actually created more differences between my premise and conclusion statement. So contraposition is probably kind of a dead end. Now, I know, though, that another thing I can do to A statements is I can apply the rule of subalternation when I'm assuming that the A statement is true. So if all A or B is true, then by subalternation, some A or B would also have to be true. And what that tells me is there is a way I know to eliminate at least the difference in quantity, because when I subalternate all A or B, I generate a particular statement that has a known truth value. Of course, I could also apply the rule of aversion to all A or B, because I'm allowed to avert anything. And when I avert a statement, the new statement's going to have the same exact truth value as the statement that's been averted. So if I avert all A or B, I've got to do two things. I've got to change its quality, but not its quantity. In other words, make it a no statement. And then I have to replace the predicate with its term complement. Okay. Now, because I can avert anything, that new statement I've generated, no A or non-B, will also be true when we're assuming that the premise statement, all A or B, is true. And now think about what I've done by applying this rule of aversion. I've actually eliminated two differences in my statements, because now I have a statement that has the same quality as the conclusion. They're both negative, and we've got matching predicates now. We've got non-B. So by just applying the rule of aversion, I've eliminated two differences, and I have to just contend now with the difference in quantity that exists. Because no A or B is universal, and my conclusion statement is some A or not non-B, which is particular. But again, I can apply the rule of subalternation. If no A or non-B is true by aversion, then by subalternation, some A or not non-B would also have to be true. Okay, now think about what we've done here. We've said, look, I can prove this argument valid by averting and then subalternating the premise statement, or by subalternating that premise statement and then averting that statement. So I can move across the top of the square and down, or down the square and across. Yeah, either way proves that argument to be a valid. The conclusion statement will have to be true. It'll have to be true by subalternation and obversion when we assume the premise statement is true, or by obversion and subalternation. Now, of course, you know, the problems you're going to be dealing with are not going to be quite that simple. They're going to involve words, okay? So this is going to require you to actually work through these problems pretty methodically. And I'm going to ask that you take a chance, give yourself an opportunity to practice this right here, okay? I have 4 steps for you that I would like you to use in order to evaluate this argument. I want you to identify the terms and reduce the terms down to 2. I want you to symbolize that argument. That is going to be so key. You want to symbolize that argument, and then you want to begin this process of identifying differences between the premise statement and the conclusion statement. And that's going to be way easier to do if you've symbolized out the argument. And then the hard work. Identify those operations and rules that can be applied to the premise to create the conclusion, and be mindful of the order. Sometimes it's going to matter when you convert a particular statement, because you can only convert E and I statements. Okay? So why don't you do this? Here's the argument. Some people who recognize paranormal events are not non-scientists. Therefore, some scientists are people who recognize paranormal events. So what I want you to do is I want you to pause the video. I want you to work through these 4 steps. Trust me that you'll be so glad you did this, because it's good practice for dealing with the kinds of problems you're going to be dealing with in your homework. And when you're ready to check your work, go ahead and restart that video. All right, let's see what we did here. First thing we want to do is we want to identify our terms. We've got 3 terms here. We've got people who recognize paranormal events, scientists, and non-scientists. We got to get rid of one of those terms, okay? And I'm going to suggest that in order to symbolize the argument, and I'm going to suggest we get rid of non-scientists, because in order to say scientists, if non-scientists is our term, we'd have to say non-scientists, which is kind of goofy, because it's not nearly as easy to say it's not a non-scientist, it's a scientist. Okay, so now we've got our 2 terms. I selected R and S. Doesn't really matter what letter you selected, as long as you've got it whittled down to 2 terms that are reflected by this argument. And now we can go ahead and symbolize. Some R are not non-S. Some S are R. We have to catalog our differences. I see a couple. Difference in quality. This premise statement is negative and the conclusion is affirmative. I also see that S and non-S are a part of this argument, right? That non-S is the predicate of the conclusion, and S is the subject of, non-S is the predicate of the premise, and S is the subject term of the conclusion, which brings us to our 3rd difference. The subject and predicate terms are in different positions. R is the subject of the premise statement, but it's serving as the predicate of the conclusion statement. So how do we apply our rules and operations to that premise statement to generate the conclusion statement? Well, first easy thing to do is we could get rid of a couple of things here by obverting the premise statement. If we obvert some R are not non-S, we're going to get the statement some R or S. And now we've got the conclusion statement of our argument and this new statement we've generated sharing quantity. They're both particular. And we've gotten rid of that non-S. So now we have just the term S. So then the question is, all right, what can I do to the statement some R or S in order to generate the statement some S or R? Did you say conversion? Exactly. If I convert some R or S, knowing that that statement would be true by obversion from the previous statement, then some S or R would also have to be true. And that's exactly what the conclusion statement says. And so therefore, we've proved this argument valid by obversion and conversion. One thing to take note of with this argument is obversion and conversion have to be applied in that order. Because if we begin with conversion and we convert this premise, we will have committed illicit conversion, because we're not allowed to convert O statements. All right, so we want to make sure we get the order of operations correct and indicate them in that correct order when we are proving an argument to be valid or invalid.